All right, here's lesson 10.2. So this is solving square root equations. We can do this with or without calculators. I would prefer without, but if the numbers get pretty big for you, then you can use a calculator. So we're going to start with the fill in the blank. So a square root equation is an equation that contains a square root with a variable, usually x, right? But with any type of variable in the radicand, so underneath the square root symbol. To solve a square root equation, we need to use the properties of equality to isolate, which means get by itself, the square root by itself on one side of the equation, then use the following property. So we're going to use this property. And we did this just in 10.1. So that last example where I said we could use a graphing calculator or we could do it algebraically, we did this key idea. So here is the key idea. So in words, if two expressions are equal, then their squares are also equal. And their squares are also, put that down here, equal. So what does that look like on the algebra side of it? They're saying this: if we have a equaling b, then a squared equals b squared. So that's going to help us to where we can now use that idea. And again, like I said, we used it earlier on to solve these equations. So let's look at example 1. Example 1, we use the properties of equality. So we're going to try to isolate this square root symbol. So the first thing we would do, subtract 5 from both sides. You get the square root of x equals 8. Now this is the new idea here, is we can actually get rid of the square root symbol by squaring each side. So we're going to square this side, and we're also going to square this side. When we do that, these cancel each other out. We get x equals 8 squared is 64. So that's our solution to letter A. Letter B, same thing. Draw the line. We need to isolate that square root of x. So the first thing I'm going to do is get rid of that 3. It's a positive 3, so I'm going to subtract it. Don't forget that there's that negative symbol still in front of the square root of x equals a negative 3. The square root is not by itself yet, so we need to get rid of this negative symbol. Remember, there's a negative 1 there, so that invisible 1 divided side by negative 1, we end up with the square root of x equals a positive 3. Negative 3 divided by negative 1 is a positive 3. At this point, we do exactly what we did up above. We got the square root by itself. To get rid of it, you square each side. 3's cancel out. And you get x equals 3 squared is 9. So just solving equations, but at the end, when we get that square root by itself, here's my daughter's fingers. All right, Brielle. We end up doing that squared at the end. All right, so here are some on your owns. We have 4. So this is where I encourage you to pause and try these on your own. But for number 1, it's already by itself, right? The square root is already by itself. So we square each side right away. So this one's quick. It's just one step. We get x equals 6 squared is 36. For number 2, I need to get the square root by itself. So the first thing I need to do is add 7 to both sides. You get the square root of x equals 10. Get rid of that square root symbol by squaring each side. You get x equals 100. Right here, properties of solving equations here of equality. Subtract 15 from both sides. You get square root of x equals 7. Get rid of that square root by squaring each side. And you get x equals 49. And then the last one, this is a lot like that second example we did, where we first have to subtract 1 from each side. You get negative square root of x equals a negative 3. Divide by this negative 1. and we get the square root of x equals positive 3. We actually end up with that same answer of x equals 9 when we square at the end. So those are the on your own. So here's that. All right. So now we can make it a little bit more complicated. So we go to example 2. You see that there's more than just x underneath the square root. So there's more in the radicand. So we still need to get the square root by itself. So to solve this, we start by subtracting this 3 from each side. We have 4 times the square root of x plus 2 equals 16. Then this 4 is being multiplied by the square root. So I'm going to get rid of that, right? By dividing the whole thing by 4. You get the square root of x plus 2 equals 4. Then go talk to mama real fast. Yep, go talk to mama real fast. Hey mama, can you come grab her? Thank you. And then at this point, we square each side. And we get x plus 2 because the square root and the square cancel each other out. And then we get 16. So this is the only difference now, is now we're not solved all the way. We just have to do one more thing. We subtract 2, and you get x equals 14. So similar idea, just having a longer process to get to the answer. So again, 2 on your own. Stop the video, try these on your own, and then check your answers. Right here, the first thing I would do to get the square root symbol by itself is I would subtract 7 from each side. You get the square root of x plus 4 equals 4. Then I need to have the square root by itself, so I need to square it to get rid of the square root. You get x plus 4 equals 16. And then you subtract 4 from each side, and you get x equals 12. There's your answer. And then for number 6, the first thing I need to do is divide by 8. Divide by 8. Cancels out, you get the square root of x minus 1 equals 3. Then I need to get rid of the square roots. Get rid of the square roots. Squared each side. These cancel out, you get x minus 1 equals 9. And then you just add the 1 at the end. So that's the last part to solve this. And you have your solution of x equals 10. All right. Now, the next one is, what if we have square roots on each side? Well, if we have square roots on each side, we can still use that same property. We can still square each side. And if we do that, it would look like this. So see how they're by themselves. So we can square each side. The square roots and the squares would cancel each other out, so we'd be left with 2x minus 1 equals x plus 4. At this point, we can then just solve this. So I would move the variables. I would subtract x from each side. X minus 1 equals 4. And then I would add 1. Add 1. And you get x equals 5. So we're going to just start off by squaring each side, and then you just solve equations just like we always have done. So then we have 2 examples that are just like that, where we have square roots on each side. So we just square each side and you'd solve. So again, I'd encourage you to stop the video right here and solve. So if I solve number 7, if I square each side, they would cancel the square roots out, and it'd be 3x plus 1 equals 4x minus 7. I then have to solve this equation, and I would subtract 3x from each side. You get 1 equals x minus 7, and then you add 7 to each side, getting x equals 8 as your solution. For this one, square each side, still because we have the square roots. You get x equals 5x minus 1. I would then, technically you can do 2 things here. I like moving the smaller variable, but let's say I move the larger variable. subtract 5x, subtract 5x. 1x minus 5x is a negative 4x equals negative 1. And then you just divide by negative 4 here, and you get a positive 1/4 as your solution. Now, the last thing here is an extraneous solution. So we're going to talk about getting these extraneous solutions. So it says squaring each side of an equation can sometimes introduce a solution that is not a solution of the original equation. This solution is called an extraneous solution. Be sure to always substitute your solutions in, right? So we always tell you that as math teachers, substitute your answers back in to make sure they work into the original equation to check for these extraneous solutions, because sometimes they won't work. And that's when you'd say, oh, well, this isn't my answer, it's gonna be my other one. So all these ones up above, there's only one solution. I'm gonna show you ones that have multiple solutions, and this is gonna be like the quadratic equations that we used to solve. So here is example 4. You see that the square root is all by itself on this side. So we'd say, oh, let's start to solve this. Let's square each side. Well, when we square the left side, we get x squared equals, and then the square root cancels out right here, x plus 6, right? And so the difference here now is that we have an x squared, and this should remind you of quadratic equations. If we want to solve this, so many different ways to do it, but I would set this equation equal to 0. So I'd bring the x over here and bring the 6 over there as well. So I'd have to subtract the x, so you'd get x squared minus x equals 6, and then subtract the 6, you would get x squared minus x minus 6 equals 0. So we set this beginning one right here to 0. Now there's multiple ways to solve this now. You can use the quadratic formula, you can factor, you can even do complete the square. I would encourage you to either do the quadratic formula or factor. I'm going to factor this. So I'm going to say, okay, with this trinomial, what factors of negative 6 add up to a negative 1? And the two factors are going to be a negative 3, so x minus 3, and a positive 2, x plus 2. So I factored that, right? The negative 3 times 2 equals negative 6, negative 3 plus 2 equals negative 1, and then we can find two solutions here. Our two solutions would be set each one of these binomials equal to 0. X minus 3 equals 0, and then x plus 2 equals 0. That's that zero product property. Solve each one. So you add 3 to this one, you get x equals 3, and then subtract 2 to this one, we get x equals negative 2. Now this is where you have to, if you get two solutions, check to see if they work, right? So you can substitute them back into your original equation that we started with right here. And I'm going to use this space over here to work that out. So I'm going to substitute 3 in. So it'd be 3 equals the square root of 3 plus 6. We're going to see if that checks out. And when I look at this, does 3 equal the square root of 9? Yes, that checks out. So this for sure is one of my solutions. It could also be this one too, so we got to check. So we put negative 2 in. Does negative 2 equal negative 2 plus 6? Right, so does negative 2 equal the square roots of 4? And we know there can be two solutions to this, so for this chapter, we're going to only think about when we take the square root of a number that it's just a positive. So this is negative 2 equals square root of 4 is 2. Does that work? No. So this is an extraneous solution. Okay, so just for this chapter, I know I told you before the square root of 4 is both negative 2 and 2. Just for this chapter, just think of it as the positive one. So that's my one solution there is 3. Okay? So that was our last example. We'll get to the Pythagorean theorem, which we're familiar with next week. So if you have any questions, let me know. I'll get you more IXL lessons to help you practice each one of these. Have a good day.